Hi friends, welcome to Gate Academy. In this video, I will give you a brief introduction on the topics I will be discussing in the PD/GD courses. I mean, what is PD/GD courses? It is pen drive and G drive courses. Many people might be knowing it. In this, all the videos I will be given to you in the pen drive format so that you can prepare on your own whenever the time permits for you. By using the pen drive, because videos are recorded and you can prepare for the various exams like GATE and ESE and practice through the booklets or by using the test series. In this video, the subject I am going to discuss is geomatics engineering. The weightage for the geomatics engineering in GATE is 4 to 6 marks and in engineering service examinations is 20 to 40 marks. This is, if you ask me, this is more amount of weightage and it is best scoring marks, because you are doing more or less, you are dealing with the surveying from your childhood. It is just application of your common sense. Use your common sense and you can get 100% of marks in the surveying, not like 80% or 60% in geotechnical engineering or environmental engineering. 100% of marks. There is no twisting, there is no lengthy questions, direct application of your idea, direct application of your formulas, and you will get the answer. So now in this, I have divided this into the 14 chapters, whole geomatics engineering. The first one comes as the basic concepts, and see here the more or less all the questions will be of theoretical type, and very less number of times you will see, like in mistakes and errors you will see the questions being asked in problems, but more or less the questions will be of theoretical type. So first one is objectives of surveying. Why you are doing surveying? Surveying is majorly done. Why? It is because of location. It is majorly for location of a point with respect of the other points, right? It is for location of a point, or it is used for what? It is used for measuring the areas and volumes, right? So all those things comes, like it is used to get the map of the ground. For that also it is used to get the levels of the ground, how the cross section look like, how the elevation look like. In order to get all those things, we will do surveying. That is the objectives of surveying. And types of surveying, it depends on the function. Like if military people does that is military surveys, and if you want to get the topography, you will get the topographical survey. You will go for hydrological survey in order to find out the groundwater levels. So it depends upon the function, and it also depends upon the instrument you are using. If you are using chain, it is called chain surveying. If you are using compass, it is called compass surveying. If it is using theoretical surveying, tachyometric surveying, leveling. So it depends upon the functions, and it also depends upon the instrument you are using. So that is how the surveys are being classified. And principles of surveying. So in depth, each and everything will be discussed in detail. And then principles of surveying. Principles of surveying is like location of a point with respect to the two known points. So that means the distance between these points might be knowing, angle between these points might be knowing. Based on the two known points, you have to mark the third point. That is the principle of surveying. And the other one is working from whole to part and part to whole. What is this, and how the errors will be reduced if you are working from whole to part but not from part to whole? Everything will be discussed in your PD courses. Next, scales and types of scales. What exactly is scale? I mean, generally you would have heard scale is map distance by the ground distance. That is the scale, that is representative fraction, and by using that we are going to generate different types of scales like linear scale, diagonal scale, vernier scale, retrograde vernier, and the combined scale, right? So there are different scales that comes into the picture. So that will also be discussed in detail. That means each and every scale, what is the least count of each and every scale, what is meant by least count actually, and what is the least dimension that can be measured. That is called actually least count. How you are going to find out the least count, everything will be seen over here. Next, mistakes and errors. What is exactly error? that is observed value minus correct value, and what is the correction you are going to give for the error. If error is positive, correction is negative. If error is negative, correction is positive. How you are going to apply that in the questions and problems will be seen in the mistakes and errors. Now this is the basic concepts that you will see. Now coming to in-depth detail, like I said, classification of survey, change survey. Change survey means linear measurement, that is measurement of lengths. So the second chapter is linear measurement, measurement of lengths. By using chains you are going to do this. The chain is generally of 30 meters length, 20 meters length. Chains, nowadays people are using tapes for measuring the lengths. You can use anything, chains or tapes. The idea is to measure the linear length. Linear length I am talking over here is horizontal length. So you know, in the surveying, in the types of surveying, if you see, there will be plane surveying and geodetic surveying. Plane surveying means if you don't consider that as curvature of the ground. How generally earth is in the form of globe. It is in the form of globe. So we have to consider the curvature between any two points. If you consider the curvature, then it is called geodetic surveying. If you don't consider that curvature and say that if you don't consider that curvature and you are saying this is the horizontal distance, then it is plane surveying. If you consider the curvature, correct it and calculate the horizontal distance, then it is called geodetic surveying. So here in the chain surveying, you are using the tapes to measure the lengths, and because of that tapes there might be errors and corrections. Errors may be because of standardization, because of pull, because of sag of its own weight, because of temperature, because of slope. If error is negative, you have to give positive correction. That means these are the errors while measuring. So in order to get the correct length, you have to do the corrections. So the errors can be because of anything. As I said, it can be because of temperature. If temperature is more, the chain would be expanded. So whatever the length you measure is less than that, whatever the length you measure is more than that of the actual length. So the correction is negative. That is the idea. So error is positive, correction is negative. So if it gets shrink, if it gets this one, so if it gets expanded, you have to keep all those things in the mind while doing chain surveying. And how exactly it is helpful, like let us say this is a line. From this line, the this house is at this distance from this line. There could you can draw perpendicular offset, you can draw oblique offsets, perpendicular offsets, oblique offsets. What is perpendicular offset? Perpendicular offsets is like, from this line, the perpendicular distance for this object you are measuring, right? That is also called as perpendicular offset. So by using cross tuff is an instrument which is used to draw the perpendicular line. So that is offset. With the help of those offsets, I will say that with respect to this line, this church is at this distance, tree is at this distance, temple is at that distance, residential school is at that distance. So all those things, in practical exposure, there is level field books. Some books called as level field books are there. In that books, you will record all these things. So linear measurements means it is locating the position of the object with respect to the two other objects or one main station. That is the idea. Now limiting length of offset means this is the length of the offset, like length of the offset. I am giving an idea, length of the offset, so that the error, as we are saying that we are assuming this as plane surveying, but in actual this is geodetic surveying. So the error in the measurement is very, very less. So if you take more length, error will be more. If you take lesser length, error will be very, very less. So the limiting length of offset is the length at which error is very, very less. And how much less? It is very less, that is 0.035, and all those things. Limiting length of offset by angles also we can calculate. How you are going to calculate, we will see in our PD course. But that is the idea. Limiting length of offset will also be discussed. And here this limiting length of offset, this errors you know the errors and corrections will be 10 marks questions or 20 marks questions in your ESC, and only one correction if they ask, that would be 2 marks questions in your GATE. So, and limiting length of offset, directly people will directly ask those questions. Sometimes they will try to twist, and we will see those type of problems also, and this can also be asked in the GATE examination. In engineering service, for 5 marks they may ask, but it was never asked, but in GATE examination they have asked this one. So, this is important. Every year you will see a question from linear measurements. Next, coming to compass surveying. Compass surveying means compass is an instrument which is used to measure the horizontal angles, right. So, there will be a needle, with respect to that needle you will keep on measuring the angle, right. So, that is compass surveying. Here linear measurement means measurement of lengths, compass surveying means measurement of angles, angle between any 2 points. So, for that, with respect to some standard direction we have to measure the angle, right. That standard direction, you know, generally we consider that as true meridian. True meridian is the line joining the north pole and south pole, and the point on the surface is generally considered as true meridian, and magnetic meridian is the direction of the needle shown by the direction shown by the needle, that is considered as magnetic meridian, that is magnetic north we generally call that as. So, true meridian and magnetic meridian, and we measure the angles. In the compass actually we get the angles based on magnetic meridian, but not because of true meridian, and the angle measured with respect to the north is called as bearing. With respect to the north it is called as bearing. So, that is true. With respect to true north it is called true bearing, with respect to magnetic north it is called magnetic bearing, and based on this you will give a designation for the bearing: whole circle bearing system or quadrantal bearing system. That means in each and every quadrant you will measure the angles, or in whole circle you measure the angles from 0 to 360 degrees, that is it might be from 0 to 90 degrees, it could be 30 degrees, it could be 120 degrees, 180 degrees, or it could be 240 degrees, 320 degrees. Whereas in quadrantal bearing systems you will see, in quadrantal bearing system you will see that, you know, north 30 degrees east, north 20 degrees west, or south 30 degrees east, south 20 degrees west. This is how you will measure in quadrantal bearing system, and how to convert whole circle to quadrantal, quadrantal to whole circle will be discussed in your PD course. And magnetic declination, always true north will not be same as that of magnetic north. There will be always some declinations or some changes. That means true north, magnetic north might get deflected with respect to true north because of the local magnetic flux. So, the name itself says it is magnetic north or magnetic flux. So, the needle always deflects towards the magnet or places where there is more attraction. So, there will be some change, right, that is called, or some difference between true meridian and magnetic meridian, true north and magnetic north. So, that is called declination, magnetic declination. And there is one more thing called as dip. Dip is, instead of the needle being horizontal, it moves like this, that means the vertical angle. So, there is some dip over here, that is also because of the magnetic flux in this region, that is called dip. And now based on this one you will measure the fore bearing and back bearing in a closed traverse. By using the compass you will draw a traverse. Traverse means it is a closed figure like A, B, C, D, E, A, that is closed traverse, closed compass traverse. By using the angles you will draw the traverse, and for each and every point you will say fore bearing and back bearing. Let us say for a line, fore bearing is AB, back bearing is BA. Generally the difference between fore bearing and back bearing should be 180 degrees. If it is not 180 degrees, we will say that the station is affected by local attraction. Local attraction means there might be because of the natural calamities, there might be change in the magnetic flux over there. So, the bearing is changed. If bearing is changed, you will say it is affected by local attractions. So, you have to come over those local attractions by using different methods, which we will see in the traversing now. So, by using compass, by measuring the angles, you will draw a traverse, that is called as compass traverse. And by using local if it is subjected to local attractions, how the error is reduced, how is the error is reduced, and how the correction will be given to each and everything will be discussed in your PD courses in depth. But if the angle between forebearing and back bearing is not 180 degrees, then we call that the station is affected by local attraction. Now, pure light. Pure light is an instrument which is used to measure both horizontal distances and vertical angles. Both horizontal distances and vertical angles is measured by using theodolite. Here the the idea in the theodolite, the direct questions will not be asked. The applications will be seen in the trigonometrical leveling. The questions that will be asked in the theodolite is like what are the temporary adjustments, what are the permanent adjustments. Temporary adjustments, the crosshairs are not exactly perpendicular to each other. So, and then bubble is not at the center, bubble is not at the center at all the points, and there will be horizontal axis, there will be vertical axis, and you have to see different axes, and whether each and everything is perpendicular to it or not, and the line of collimation meet exactly at the center or not. You have to see all those things, and based on that you will go for temporary adjustments and permanent adjustments. Generally it would be centering, leveling, all these things comes under temporary adjustments, and if the horizontal hair is not perpendicular with the vertical hair, all these things comes under permanent adjustments. Temporary adjustments will be done in the field, and permanent adjustments as to the equipment will be taken to the laboratory and it is changed over there. That is why it is called as permanent adjustments. Now, coming to this one, as I said, theodolite is used for measurement of horizontal length and vertical angles. That means by taking the readings, how you are going to measure the horizontal length, how you are going to measure the vertical angle will be discussed in detail in this theodolite concept. Next, traversing. Traversing, as I already told you, traversing means closed traverse, means it is a closed figure A, B, C, D, E. Let us say a pentagon A, B, C, D, E, and then if you finally close that E to A, then A, B, C, D, E, A is a closed traverse. So, there will be included angles. So, the sum of the angles inside a traverse or inside a polygon is 2n minus 4 into 90 degrees. So, if it is not 2n minus 4 into 90 degrees, that means one angle is affected because of local attraction. So, you have to calculate what is that angle, you have to compensate that error. How you are going to compensate that error, how finally you are going to find out the forebearings and back bearings. As I said, the local attractions that problem will be solved in the traverse, that is balancing angle of traverse. So, that is by you can do that by balancing angle of traverse method, or you can calculate latitudes and departures. For a closed traverse, sum of latitudes and sum of departures both must be 0. So, what is latitude? What is departure? So, its projection with respect to north south plane, with its the line projection with respect to east west plane. So, that is one thing is called latitude, other thing is called departure. So, for a closed traverse, summation of attitude and summation of departures is equal to 0. If it is not 0, how you are going to compensate the error, and that is the adjustment of traverse, that is by using Bowditch method, and there is graphical method also, there is transit method also. So, different methods are used where based upon the precise of linear measurement and angular measurement, Bowditch method or transit method or graphical method is used for adjustment of the traverse. So, all these things will be discussed in the traversing. Next, contouring. What is contours? contours is the line joining points of equal elevations is contours, right. So, we will draw the contours. Based upon the contours, you can measure the areas and volumes of a map. Based on the contours, you can measure the areas and volumes of the maps. How you are going to measure that? That will be discussed by using some of the problems. And you can also mark the road on the map. That means what is the direction of the road that you have to provide, that can be marked with the help of the contours, right. So, I mean types of contours, here also different places where you can provide the contours can be discussed. And like we say that two contours do not meet, that means one contour is at one elevation, other contour is at other elevation. So, what are the exceptional cases? Like overhang cliff is an exceptional case. So, that means it is not meeting exactly in the field, but we are showing that it is meeting in the map. And how come a valley comes and how come a ridge comes? So, all those things will be shown in the contouring. So, all these things will be discussed in contouring. Now, coming to leveling. Leveling means, leveling is used to get the reduced level. What is reduced level? Reduced level of a point is the elevation of the point with respect to benchmark. Benchmark can be taken as sea level, or the nearby benchmark can be taken. I know the elevation of that point is 150 meters with respect to the mean sea level. So, with respect to this one, I will measure the elevation of the top level, or I will measure the elevation of this beam. So, from here to here, or this slab, from here to here, I will measure the distance. So, finally, I will get the reduced level with respect to the mean sea level. That is the idea. With respect to mean sea level, I know this elevation is 150 meters. Elevation means what? Height. With respect to mean sea level, this point is 150 meters. This point is 3 meters. So, totally it would be 153 meters. That is the meaning of it. So, and based on this, you will get the profile. By using the leveling, you will get the profile of the ground, whether it is going like this or like this, like this, like this, like this. So, or it is rising or it is falling like this. All those things you will get from the leveling. In the leveling, you have to correct all the levels based upon the effect of curvature and refraction. And leveling is methods of leveling, height of instrument method or rise and fall method, all those things. What is benchmark, what is reduced level, what is elevation, what is foresight, what is back sight, what is intermediate sight, what is height of instrument, arithmetic check, all those things. That is summation of foresight minus summation of back sight is equal to last RL minus first RL. All those things will be seen as the arithmetic check. Next, sensitivity of the bubble tube, where when there is a level, we use dumpy levels. So, bubble tube will be there. In the bubble tube, the bubble has to be exactly at the center. If either moves if it moves somewhat front or somewhat back, we will say that it got affected. It is more sensitive. Instrument is more sensitive. So, you have to get the bubble at the center, or if you are not getting the center, you have to mention the sensitivity of the bubble tube. Indirectly, it is also an error that has to be fixed while taking the readings by using the levels. And as I already told, there will be correction due to effect of curvature and refraction on the levels. So, that effect should be taken on RLs, because it is not exactly straight. Earth is not exactly straight, Earth is somewhat curved. That is what we do in geodetic surveying. I have already told you that, right. So, that will be discussed in detail, how you are going to show the effect of curvature and refraction on RLs. Next, tachyometry. Tachyometry is also an instrument which is used to measure the angles and horizontal distances. Here you will see the stadia hair. There will be 3 hairs in this. So, middle hair, top hair, bottom hair. Based on this, you will get the 3 angles, and based on that you can exactly measure the horizontal distances, elevations and all those things. And trigonometrical leveling is totally based on tachyometer. So, here you will measure. Here you can measure the horizontal distances by using the chain and vertical angles by using the levelings. But here the tachyometer is very much helpful, where you will measure both horizontal distances and vertical angles. So, trigonometrical leveling, here it is used to give the RLs or elevations of various churches, church towers. Let us say I want the height of the church tower from with respect to this one. You are here, it is somewhere on the top of the mountain. By using tachyometer and by applying trigonometrical laws, that is basic sine thetas, tan thetas, you will get the values of elevations. And here the different concepts would be staff kept normal, staff kept vertical, staff kept normal, and then elevation, and then you can see if it is below this one, and you will also find out the, if you want to find out the RLs, you also can find out RLs for all those things. So, in depth with respect to the problems will be discussed in the trigonometrical leveling. Now, coming to plane table surveying. The name itself says plane table surveying is very simple. There will be a tripod, there will be a table, on the table you will keep the chart, and on the chart with the help of alidade means it is indirectly a scale where you will be having two slots. From one slot is kept open, in the other slot there will be a small thread, and there will be a ranging rod. A person will be carrying a ranging rod over there, and from here you will sight that person, you will measure the distance, and you will show that distance on the chart. So, in plane table surveying you will be doing four things. First one is radiation, second one is intersection, third one is traverse, fourth one is resection. Radiation means noting down the points or plotting the points on the map. Intersection means intersecting plotting the third point by using two other points, and by intersecting distance from these 2 points you will plot the third point. That is the major objective of the surveying. So, that is one thing. And traversing means, I have already discussed. Traversing means creating a complete pentagon or create a complete polygon. It could be pentagon, hexagon, anything. So, that is the thing. Resection means, resection is a method in which is used to find out the ground position. That means today you have started your surveying from this point, but due to rain the arrow was removed, or some calamitous arrow was removed. Tomorrow you have to find out that point with the help of the plotted points. So, that is called resection method. You will use 3-point problem, 2-point problems, and all those things will be discussed in the plane table surveying. Next, coming to curves. Curves could be horizontal curves. Horizontal curves means like this, and it could be vertical curves, summit and valley curves. So, in horizontal curves there could be simple curve, compound curve, reverse curves. So, these are horizontal curves. We will be discussing horizontal curves over here. And this horizontal curves, setting of horizontal curves. It could be linear method or angular method. In linear method means the name itself says linear measurements, that means offsets. We are going to measure the offsets from a point. So, it could be setting of the curve by offset of card produced method, and setting of the curves from the offset method. All those things comes in this linear method, and in angular method 1 theodolite method or 2 theodolite method is seen in the angular method. That is how you are going to set the curves. Here you are going to measure the tangent distance, apex distance, and then length of the curve, degree of the curve. All those things is used to set the curve. Set the curve means actually we are setting the curve on the field. We are setting the curve on the field, and that is done by all these methods, curves. So, your major gate questions is generally from trigonometrical leveling, and if they wants to ask you theory is asked from plane table surveying and levels. Sensitivity of bubble tube, effect of curvature on RLs and refraction, effect of curvature and refraction on RLs in different types. I said methods of leveling, just simple plain leveling you can take, or you know, sometimes in order to correct research, I mean here in methods of leveling, you know, at two banks you will keep the level staffs. At two banks you will keep the level staffs and you will measure the angles, you measure the distances. So those type of problems you is also very much asked from methods of, I mean those type of problems. Indirectly we can see that indirect method of levelings that can also be discussed, that will also be discussed, because more number of problems is asked from that point also. That means generally, you know, if you take level from the nearby, it is correct. If the level is from far, it is wrong, because of effect of curvature and refraction, and sometimes because of permanent adjustments. And how you are going to compensate that error and correction to that error will also be seen here, and that is majorly asked for gate. And this bending moments, RLs, elevations, foresight, backside, arithmetic check, this is generally seen in engineering service examinations, and correction due to effect of curvature and refraction on these RLs. This is also seen in ESC examinations. Generally it is not given in your gate because it becomes lengthy, but if he wants to give, he will give you in the short form. Those type of questions will also be discussed. Next, contourings. This is important for ESC, and very rare you will see these type of questions asked for gate examinations. Next, curves also. In last year only, for the curves, for setting of curves, 20 marks question is being asked from setting of curves. So setting of curves is more important for engineering service examinations. Now after the curves, there is theory of errors. Theory of errors. So here in this we will be discussing what is precision, what is accuracy, and what are systematic errors, what is compensating errors, what is cumulative errors. The name itself says everything. Compensating errors, one compensates other. Cumulative errors, which keeps on adding, that is called cumulative errors. And then there is precision. What is meant by precision, what is meant by accuracy, and weightage factors will be given to each and every measurement. So after weightages, what is the standard deviation, what is the most probable value, standard deviation, most probable value, and allocation of weights to the quantity. And because of addition, if you add two quantities, so if there is error in both the two quantities, what is the error in the added quantity? If you are multiplying it, if you are dividing it, if you are subtracting it, what is the final error in the quantity? All those things will be discussed in the theory of errors. And this is also asked for 2 marks questions, and in engineering services they will ask for 10 to 15 marks of questions. If they ask from here, in the allocation of weights, they will ask to calculate the standard deviation, they will ask you to calculate the most probable value, they will ask you to calculate the mean values. All those things will be seen in theory of errors. Now photogrammetry. Because of introduction of photogrammetry, remote sensing, field astronomy, the subject is changed to geomatics engineering instead of, before that it is used to be called as surveying. So photogrammetry means you are taking a photo from the top, or you are taking a photo horizontally, based, I mean like this, these are horizontal photographs, and if you are taking from the top, that is called vertical photographs. This photographs, by taking a photograph you are measuring the area, like by taking a photograph, if you take a photograph and I say that this object is at a distance of this from here, this object is at a distance from here, this object is at a distance of 20 meters from this point. So you can say that, right? So by taking photographs, if you are satisfying the objects of survey, then it is called as photogrammetry. So here also you will find out the scale of photo, and if it is flying, you know, it is going like this, it is taking photos, that means aeroplane is going like this and it is taking photos at various points. So this flying height can be measured, and focus and coordinates of the points can also be measured, areas can be calculated. all those things can be done by using photographs. And here tilted photographs will also be taken, but in-depth discussion of tilted photographs is not actually necessary for both ESE and GATE point of view. And recently in GATES, a definite 2 marks question is being asked from these two topics. At least 1 mark or 2 mark questions is being asked from photogrammetry and remote sensing. So that is the idea in photogrammetry, and there will be longitudinal lab, there will be lateral lab, and what is the effective area that has to be calculated. All those things will be discussed in photogrammetry. Now coming to remote sensing, GIS, GPS. A theory question, many a times, it is being introduced just 3 years back, and all the 3 years if you see a theory question is being asked, what exactly is remote sensing, and general knowledge question was asked last before a year. So those points, major points will be discussed. This is geographical positioning system, this is geographical information system, so and then remote sensing. So how exactly is this being done will be given to you, and we are going to discuss those things, and it is a theory question. And in engineering services you do not see much of these type of questions, but in GATE recently they are asking for 2 marks and 1 mark questions. And field astronomy, this is only important for engineering service examinations but not for GATE. So this is discussed from engineering services point of view. In field astronomy, it's like what is the relative position of the star, what is the time at this point. Like we are discussing the position of this object, it is like astronomy, relative position of this star with respect to zenith, with respect to nadir. What is zenith, what is nadir, what is azimuth, what are the angles, what are the linear measurements over there, and what is astronomical triangle, what are the coordinate systems you are going to give over there. All those things will be discussed. And here if at all they ask a 10 marks questions, and if you are more lucky they might ask you 15 marks questions also. Same thing, whatever you do in the trigonometrical leveling or tachyometric surveying, that is your triangulation you will do, right. That means you will draw a triangle over here, here you will draw astronomical triangle, and you will just measure the angles and relative position of the stars. And you can also measure mean time, solar mean time, and you can also see latitudes, longitudes, how exactly is latitudes and longitudes, and based on that how you are going to position an object, how you are going to calculate the distance. All those things will be seen in field astronomy. So after discussing all these things, and after completing of all these things, a booklet will be given to you, like this type of booklet will be given to you, which majorly consists of 3 parts. In the first part there will be previous year's GATE questions and ESE questions. In the last part there will be non-GATE and non-PSU questions. Both the things will be, the solutions for both the things will be dealt in this PDGD courses. Both the things will be dealt in PDGD courses, and there will be a second part which is called as practice questions, and those questions has to be done by you, and the solutions for those questions will be given in any of the social networking groups. That is, the solutions, if you post the question over there, solution will be posted to you in that social networking site. That's it. That is how. And see, geomatics engineering is more and more scoring object. 100% of marks can be achieved over here. I am telling you 100% of marks, because lesser and lesser theory is being asked. If out of 6 marks 1 mark of theory is asked, and if you know that theory, it's fine, but 5 marks you can score, and throughout the India everyone will be scoring. That means the person who is preparing seriously for GATE can easily score this. And sometimes people who don't prepare also are scoring this, because it is just application of common sense. It is just very mere application of common sense. So, and in PD courses PD courses, each and every point and each and every problem will be discussed. Thank you.